In this presentation, we will learn how to create nodes of a linked list with the help of C programming language. I hope that you have a profound knowledge on structure and pointer of C programming language, because these two features of C programming language are extensively used in linked list. Let's recap about the self-referential structure. Self-referential structure are those structures that have a pointer which refers or points to the structure of the same type. Let me show you an example. So this is a self-referential structure. Here A is the structure name, and the structure has some member variable x, y, and star next, where x is integer type, y is character, and star next is a pointer variable because pointer is denoted by this asterisk sign. So when you create a variable of this structure, it will look like this. So it has x, y, and star next pointer variable. Look at this pointer variable star next. This pointer variable is capable of holding address of the structure of the same type. If you write int in front of star next, then it will be considered as integer type pointer variable. That means it can point or refer to any integer variable. If you write float in front of star next, then it will be considered as float type pointer variable and is capable of pointing or refer to a float type variable. But here I have written struct A. That means it will point or refer to a variable which has struct A type. That means you can say that this star next is pointing to the structure of the same type. In pictorial representation, it will look like this. That means star next will hold the address of this structure. Or in other words, you can say that star next is pointing to this structure, and both the structure has the same type. Since this pointer referring to the same type, that is why it is called self-referential structure. Now this self-referential structure concept will be used in linked list. Let me show you how to write the structure of a node in C programming language. Suppose you have a node with a data part and a star link part. You can write star next, star link, whatever you like. The structure of the node will be look like this. So here the structure name is node and the member variable is data and star link. Data is of integer type and star link is of struct node type. That means it is a self-referential structure. So these are the two data type, and combining these two data type, it forms a user defined data type. So structure always forms a user defined data type. So this is the structure of a node in C programming language. Now let me show you how to create nodes by writing a complete C program. So first of all, we have to mention the header file, that is the include stdio.h, which is a mandatory header file for the C programming language. This is for standard input output. And next, this is stdlib standard library. This stdlib header file is used for the malloc function, which will be used for creating nodes. Next, let me write down the structure of the node. So it will be struct node, and within the struct node there will be two member variable in data, which contains the information part and the star link self-referential pointer. Next, main method. So I have written int main. Since the return type of main is int, so I have written return 0 at the end. Now before creating a node, we have to declare a pointer variable head which will point the first node of the linked list. Here I am not going to create a linked list. I will simply create a single node, and that node will be pointed by some pointer variable head. So let's declare a head pointer variable. Obviously head pointer variable will be struct node and it will be initialized with null. Look at the picture. So head is a pointer variable and it is pointing to null initially. Now look at the next line. This is the code of creating a node. Here I have written head equal to within parenthesis struct node star, then malloc, again an opening parenthesis size of. This is an operator of C programming language which will calculate the size of any primitive or a derived data type. And within the parenthesis struct node parenthesis close. The right hand side of the assignment operator will be executed first. So let me discuss the right hand side first, then we will talk about the left hand side head pointer variable. Now look at this segment first, size of within bracket struct node. So the struct node contains some member variable. It may be some information, that is the data, or a self-referential pointer variable. Since this primitive data type and the pointer variable occupies some space, so the size of operator will calculate the total size of the structure in bytes. and that will be passed to the malloc function parameter. M for memory and alloc means allocation. So size of operator will return the size of the structure in bytes, and that will be passed to the malloc function parameter. So by looking into the size, malloc will create some space within memory. So it will look like this. Look at the diagram. So it has a data part and a starling part. The starting address of the memory is 1000. I have taken this address arbitrarily. Now after creating the memory space, you need to typecast this memory segment to struct node type. Since this memory is pointed by some pointer variable, so it will be typecasted to pointer of struct node type. It is not mandatory. You can omit this explicit typecasting from this line. It will work same without this explicit typecasting. But I will suggest you to write this explicit typecasting everywhere. Now this memory has been created with a starting address 1000, and this 1000 will be initialized within head. That's mean the address of the first node will be copied into the pointer variable head, and it will look like this. So head is now initialized with 1000. That's mean head is pointing to this memory location, or simply the node. So whenever you create the first node, that will be pointed by some pointer variable of the same structure. You can create multiple nodes and they are connected with some link. So you do not have to point each and every node. Just make the head pointer points to the first node only. To access the node or the list of nodes, you have to start from head only. There are no other option to access the list without the head pointer variable. So be careful, head pointer variable is very important because this will be the beginning of your node or a list of node. Now the node contains the data part and the link part. Let me assign some value to this data part. Now the next line of our code will be look like this: head arrow data. This hyphen greater than means an arrow operator. So whenever you call a structure member variable with the help of a pointer variable, this arrow operator is used. That's mean the data part of the head will be initialized with 50. Next, the link part of the head will be initialized with null. That's mean the link part will be updated with the null value. As there are no other nodes, so there is no question of pointing to other node. So it will points to null. Now if you want to print the information part of this node, so what you have to do, just write down the printf statement, head of data. So whenever you print head of data, that's mean it will print the data part of this node, that will be 50. So this is a complete program of creating a node using C programming language. Now let me show you the same example by writing it into the C compiler, and there I will show you more techniques on this node creation. First of all, let me write the header file stdio.h, then stdlib. This is for the malloc function. Then let's create the structure struct node. Structure will be always end up with a semicolon. There will be one information part, the data part, and the self-referential structure struct node, and it will be link. Now come out from the structure. Now the main function, there will be a return 0 at the end of the main function. First declare the head pointer variable, so it will be also a struct node type. Since it is a pointer variable, so I have written star in front of head, and it will be initialized with null, and null will be in capital letter. Let's create the node. Since head will point to that node, so head equal to within brackets struct node. This is for the typecasting. Sorry, it will be struct, then the malloc function. For this malloc function, we require this standard library header file. Then size of struct node. So the size of will calculate the size of the structure, and that will be passed to the malloc function, and the malloc will allocate some memory space, and that memory space will be typecasted to struct node. That's mean the memory space will be converted to this structure. Now the memory has a data part and a star link pointer part. The address of the memory will be initialized within head pointer variable. Now write down head arrow operator data equal to, say I'm writing 50. Now head arrow operator next and it will be null. Let me print the information part of the node. Data equal to %d, then head of data, give a semicolon. There is one more correction. It will be returned. Okay, now run the file, save the file and then run. This is the output, data equal to 50. Now, as I have said, you can omit the explicit typecasting in front of this malloc. Save the file, run again. It will run. So you can omit the explicit typecasting which I have written in front of malloc, but still I will suggest you to write this explicit typecasting. Look at the program. I have written struct node so many times within the program. So you can give a short name to struct node. For that you require a typedef keyword struct node and give a short name, say node. Whenever you use this node word, that will be replaced by struct node internally. Okay, so just replace all the struct node with the node. The code will become a bit smaller and nothing else. Save the file, run the file. So it will give you the same output. Now this typedef keyword can be written in front of this struct node. So you need not to write this line, just delete this one and write the node in between the ending of this structure and this semicolon, just over here. Save the file and run. You will get the same output. So this is all for this video. Try to write the code of your own. Still, if you have any problem, write it down in the comment box. I will reply you back as soon as possible. Thank you.